जसं आपण एक्सटर्नल मॅग्नेटिक फील्ड त्याच्यावरती अप्लाय करत असतो त्यानुसार त्याचं वेगवेगळ्या टाइप्स मध्ये म्हणजे वेगवेगळ्या प्रमाणात मॅग्नेटायझेशन इंड्युस्ड होत असतं. त्यानुसार ते मॅग्नेटिक मटेरियलचे काय होत असतात वेगवेगळ्या प्रकारात वर्गीकरण केलं जातं. जसं की डायमॅग्नेटिक मटेरियल, पॅरामॅग्नेटिक मटेरियल, फेरोमॅग्नेटिक मटेरियल आणि अँटी फेरोमॅग्नेटिक मटेरियल. समजलं का? डायमॅग्नेटिक मटेरियल, ओके, डायमॅग्नेटिक मटेरियल, पॅरामॅग्नेटिक, फेरोमॅग्नेटिक, अँटी फेरोमॅग्नेटिक आणि फेरीमॅग्नेटिक. हे कशावरती डिपेंड असतं? एक्सटर्नल मॅग्नेटिक फील्ड अप्लाय केल्यानंतर येणारा जो रिस्पॉन्स असतो त्या मटेरियलचा, काय एक्सटर्नल मॅग्नेटिक फील्ड अप्लाय केल्यानंतर येणारा जो रिस्पॉन्स असतो त्या रिस्पॉन्सवर त्या मटेरियलचं काय होतं, किती प्रमाणात मॅग्नेटायझेशन इंड्युस्ड होतं, ओके, किती प्रमाणात मॅग्नेटायझेशन इंड्युस्ड होतं त्यानुसार त्या मटेरियलचं वेगवेगळ्या प्रकारात वर्गीकरण केलं जातं. डायमॅग्नेटिक, पॅरामॅग्नेटिक, फेरोमॅग्नेटिक, अँटी फेरोमॅग्नेटिक आणि फेरीमॅग्नेटिक मटेरियल. मग the ratio of M to H is called as susceptibility. ससेप्टिबिलिटीचा रेशो जर तुम्हाला घ्यायचा असेल तर तो ससेप्टिबिलिटी काय ने आपण डिनोट करत असतो, ओके, कशाने? काय ने. आणि हे जे असतं M म्हणजे तुमचं काय असतं, M इज द मॅग्नेटायझेशन, ओके. देअरफॉर काय इज इक्वल टू M अपॉन H. आणि त्याच्यावरून तुम्ही म्यू झिरो तुम्हाला माहितीच असतं, म्यू झिरो इज इक्वल टू बी अपॉन एच. म्यू झिरो इज इक्वल टू बी अपॉन एच. म्यू म्हणजे काय असतं तुमची परमिएबिलिटी, म्यू झिरो, ओके. त्याच्यात तुम्हाला थोडे काही काहींना फरक समजत नाही बरं का याच्यात. म्यू झिरो इज द permeability, okay, we called it as mu zero as the permeability, and this is the epsilon zero, this is the epsilon zero, we called it as permittivity, okay. It is the permittivity and it is the permeability, okay. Mu zero and epsilon zero, difference between mu zero and epsilon zero. Mu zero is permeability, epsilon zero is permittivity. Therefore where B is the magnetic induction, and mu zero is permeability of free space, permeability of free space. The permeability of medium mu is given by, okay, the given medium साठी permeability काय असेल मग तुमची, mu is equal to 1 plus 4 pi x. काय असते? mu is equal to mu is equal to mu m is equal to 1 plus 4 pi x. म्हणजे कॉमन, इट इज द कॉमन म्हणजे टाइप्स ऑफ मॅग्नेटिक मटेरियलचं परमिएबिलिटी परमिटिव्हिटी कशावरनं काढत असतात. मग ही द व्हॅल्यू ऑफ एम चेंजेस विथ रिस्पेक्ट टू मटेरियल, व्हॅल्यू ऑफ एच चेंजेस विथ रिस्पेक्ट टू मटेरियल, ओके. जसं की तुमचं मटेरियल बदलणार तसं तुमचं एम आणि एचचा रेशो पण बदलणार. म्हणजे कॉमन साठी म्हणजे मॅग्नेटिक मटेरियल्स मध्ये कसं करतात, काय इज इक्वल टू एम अपॉन एचचा रेशो घेतो. एम तुमचं वेगळं असणार आणि एच तुमचं वेगळं असणार. तसंच तुमचं म्यू झिरो परमिएबिलिटी, परमिएबिलिटी पण तसंच असणार फ्री स्पेस साठी. बी ची व्हॅल्यू वेगळी असणार, एच ची व्हॅल्यू वेगळी असणार. इट डिपेंड्स ऑन मटेरियल, ओके, इट डिपेंड्स ऑन मटेरियल. आता त्यानुसार कोणाचं तरी माहिती नव्हती का? ओके, त्यानुसार तुमच्या मटेरियलचं वेगवेगळ्या याच्यात वर्गीकरण केलं जातं. आता त्यानंतर त्याच्यातला पहिला प्रकार आहे तुमचा डायमॅग्नेटिक मटेरियल. कोणता प्रकार आहे? डायमॅग्नेटिक मटेरियल, ओके. सो व्हॉट इज डायमॅग्नेटिझम? Diamagnetic substances, diamagnetic substances means the substance which are weakly repelled by magnetic field are called as diamagnetic substances. Means when we applied, this is the magnetic material, okay, and we applied external magnetic field, okay, we applied, this is the substance and we applied external magnetic field on it, and this substance which are weakly repelled by magnet, okay, These are weakly repelled by magnet or magnetic field. Okay, repelled by magnet or magnetic field. So we called it as diamagnetic substance. Means we just know this word, weakly repelled. Okay, weakly repelled. We called it as diamagnetic material. Means when we applied the magnetic field at that time, the substance which is weakly repelled to the magnetic field, then we called it as diamagnetic material. So what are the properties of diamagnetic materials? Firstly, when material of diamagnetic substance is placed in external non-uniform magnetic field, is placed in external non-uniform magnetic field, then it moves from stronger part to weaker part of the field. Okay, then it's moved from stronger part to weaker part of the field. म्हणजे जेव्हा त्याच्यावरती एक्सटर्नल मॅग्नेटिक फील्ड अप्लाय केली जाते, प्लेस्ड इन एक्सटर्नल नॉन युनिफॉर्म मॅग्नेटिक फील्ड, at that time it moves from stronger part to the weaker part of the field. ओके, म्हणजे फील्डच्या स्ट्रॉंगर पार्ट कडनं वीकर पार्ट कडे त्याची मुवमेंट व्हायला लागते डायमॅग्नेटिक मटेरियलची. त्यानंतर त्याची सेकंड प्रॉपर्टी, in absence of external magnetic field, net magnetic moment is zero. सपोज आता हे मॅग्नेटिक मटेरियल आहे, याच्यावरती एक्सटर्नल हे सबस्टन्स आहे, याच्यावरती एक्सटर्नल मॅग्नेटिक फील्ड अप्लाय केलेली आहे. जेव्हा मॅग्नेटिक फील्ड, when we applied external magnetic field at that time, it having some magnetic moment, but we remove this magnetic field. So what happens when absence of external magnetic field? Absence of external magnetic field, net magnetic moment is zero. When we remove the external magnetic field, then its magnetic moment must be zero. Okay, then third one is the diamagnetic substance lose their magnetism on removal of external magnetic field. Means this is correlated, this sentence and this sentence is correlated. What happens when diamagnetic substance, we called it as specially diamagnetic substance. Okay, when we diamagnetic substance lose their magnetism on removal of external magnetic field, means when we applied external magnetic field at that time, it is the magnetic material, it behaves like a magnet, but when we remove the external magnetic field from this material, at that time it is a common material, means it do not show any magnetism. Okay, it do not show any magnetism. Due to that, it is a diamagnetic substance. Means diamagnetic substance lose their magnetism on removal of external magnetic field. When we remove external magnetic field, at that time diamagnetic substance lose their magnetism. Okay, diamagnetic substance lose their magnetism. Then third one is the diamagnetic materials have temperature independent negative susceptibility. Means previous slide I told you about the susceptibility. Means this susceptibility depends on your magnetic material. So what happens in the case of diamagnetic material? Diamagnetic material have temperature independent negative susceptibility. Means its susceptibility do not depend on temperature. Okay, temperature independent and negative susceptibility. Which material? Diamagnetic material. Okay, diamagnetic material susceptibility is temperature independent and negative, which is in next slide I will explain that the susceptibility equation. The magnetic susceptibility for n atoms having atomic number Z is given by, it is for diamagnetic material. Okay, therefore chi is equal to minus. Minus means your susceptibility value is negative. Okay, so here I have explained that negative susceptibility. Okay, negative susceptibility, and there is a not role of any temperature here, so it is do not depend on temperature. Therefore chi is equal to minus of n mu 0 e square z divided by 6m bracket complete a square, bracket complete a square, where a is the average radius of electrons in an atom. Okay, average radius of electrons in an atom, so it is the radius of electrons in an atom. So this is the susceptibility for diamagnetic material. This is the susceptibility of diamagnetic material is chi is equal to minus of n mu 0 e square z divided by 6m bracket completed into a square. What happens? We only just remember that diamagnetic material have susceptibility. Chi means susceptibility is negative. Okay, diamagnetic material susceptibility is negative. So what are the examples of diamagnetic materials? Firstly, antimony. Okay, you know that antimony, gold, bismuth, copper, mercury, water, air, hydrogen are diamagnetic substances. Are diamagnetic substances means when we applied external magnetic field to from all of the out of one from this material at that time, what happens when we applied external magnetic field at that time? It gives some magnetic field, but when we remove the magnetic properties at that time, what happens? Its magnetization is zero. It do not show any magnetic properties. Means it do not show any magnetic properties. So that's why we called it as diamagnetic substances. Okay, and the examples of diamagnetic is this: antimony, gold, bismuth, copper, mercury, water, air, hydrogen. Water, air, hydrogen. It is easily available. Hydrogen gas in the gases form in atmosphere. There is a hydrogen, but easily available. We have water, air. Okay. Then mercury is also in our lab. Copper is also in our lab. Bismuth also. Antimony also. Gold. We all have gold along with us. Okay. So these are the examples of diamagnetic materials. Then nextly we move toward the paramagnetism. When we move towards paramagnetism means what happens? What is the difference between paramagnetic and diamagnetic material? So what is the paramagnetic substances? Paramagnetic substances. The substance which are weakly attracted. Substance which are weakly attracted by magnet or magnetic field are called as paramagnetic substances. And here, what happens? Which are weakly repelled by external magnetic field. Okay, which are weakly repelled by magnet or magnetic field. It is the repulsion. Okay, weakly repulsion. And here, what in the paramagnetism, what happens? The substance which are weakly attracted means it is the attraction of atoms. Okay, it is the attraction of atom in paramagnetism and repulsion of atoms in diamagnetism. Okay, means in paramagnetic substance, the substance which are weakly attracted by magnet or magnetic field, we called it as paramagnetic substance. Which are weakly attracted by magnetic field, we called it as paramagnetic substance. So what are the properties of paramagnetic substances? Firstly, for the paramagnetic substance, first property is that when material of paramagnetic substance is placed in an non-uniform magnetic field, means when we place paramagnetic substance in non-uniform magnetic field, when we place paramagnetic substance in non-uniform, okay, it is a non-uniform magnetic field, then it moves from weaker part to the stronger part of the field. Okay, means this is the paramagnetic substance and it is the non-uniform magnetic field. This is paramagnetic substance, it is the non-uniform magnetic field. When we applied non-uniform magnetic field, at that time what happens? Magnetic field, then it moves from weaker part to the stronger part of the field. Okay, then it moves from weaker part to stronger part, means in this part, suppose this is the part that having the weaker atoms. Okay, this is the part which having the atoms which have a strong magnetic field, or nothing to that. If this is the magnetic field which having the strongest part, okay, strongest field, at that time what happens? And it is the suppose and below that this is the weakest magnetic field in downward direction and strongest magnetic field in this perpendicular direction. So what happens? What happens? Atoms move toward the stronger part of the field. Okay, means it is the stronger field, and suppose it is the weaker field. So what happens? The atoms move toward the stronger field, not the weaker field. Okay, atoms move toward the stronger field, not the weaker field. Then these are the paramagnetic materials. Means when material of paramagnetic substance is placed in an non-uniform magnetic field. Okay, in a non-uniform magnetic field, then it moves from weaker part to stronger part of the field. Then it moves from weaker part to the stronger part of the field. Then second one is the in absence of external magnetic field, net dipole moment of atom is zero. Okay, means this is the magnetic material and external. This is the external magnetic field. If this external magnetic field is zero or not applied, means we not applied external magnetic field here. So what happens? Its dipole moment of atom is zero. Its dipole moment is zero. Same as that of previous properties of dimagnetic material. The third one is the material having some net magnetic moment present on atoms. Present on atoms. The material having some net magnetic moment present on atoms, molecules or ion, even in at zero magnetic field. Okay, if there is there is a zero magnetic field at that time, what happens? The net there is a some little part. Okay, there is a little part of the magnetic field. There is a little part of magnetic field present in their atoms, molecules or ions. The material having some net magnetic moment present on atoms, molecules or ions, even in the zero magnetic field. Even in the zero magnetic field means at the zero magnetic field it's having some magnetic moment. Okay, it having the magnetic moment at zero magnetic field. Then what is the next property? The magnetic susceptibility. Magnetic susceptibility is very much important for that. Magnetic susceptibility in case of paramagnetic substance is inversely proportional to the temperature. Okay, means it is inversely proportional to the temperature. Means as the temperature increases, magnetic susceptibility decreases. In previous case, what is in the case of diamagnetic material? In the diamagnetic material, it is do not depend on temperature. Means magnetic susceptibility of diamagnetic material do not depend on temperature, but magnetic susceptibility of paramagnetic material is depend on temperature, but it is inversely proportional. Okay, it is inversely proportional. And means there is a difference between what is the difference between diamagnetic material and what is the difference between paramagnetic material. At that time you must be differentiate between the diamagnetic material and paramagnetic material. What is the first difference? You know the first difference. uh, Diamagnetic material which are the weakly repelled, and paramagnetic material which are the weakly attracted to the magnet by external magnetic field. This is the first difference. Means there is a repulsion of magnetic field in diamagnetic material. In paramagnetic material, there is the attraction of magnetic field. Then second one is the what is the second part? Second part, if we get the second part, susceptibility. Diamagnetic material have a negative susceptibility, and it is independent on temperature. And paramagnetic material each having uh, its susceptibilities depend on temperature, and it is inversely proportional to the temperature. Then other properties are also there. Means paramagnetic material have non-uniform magnetic mood, weaker part to the stronger part. Okay, means its magnetic field, non-uniform magnetic field moves from weaker part to the stronger part of the field. Then what happens in diamagnetic material? It moves from the stronger part to the weaker part of the field, and its net magnetic moment for the at zero magnetic field, diamagnetic material is zero. But net magnetic moment at zero magnetic field is some magnetic moment.
Sir, weaker part to stronger part ना.
Yes, yes, part of
तुम्ही stronger to weaker म्हणला.
the weaker part to stronger part paramagnetism. Okay, and here it is stronger part to the weaker part in diamagnetism. Okay, means there is a difference stronger part to weaker part for diamagnetic material, and here weaker part to stronger part. Okay, weaker part to stronger part for the then net magnetic moment. Next point is the net magnetic moment present. There is some net magnetic moment present on atoms, molecules, or ions at zero magnetic field in paramagnetic material. Means there is a some net magnetic moment present. Net magnetic moment present at zero magnetic field in paramagnetic material, and uh, net magnetic moment in diamagnetic material is zero. Then we move toward the magnetic susceptibility. Then we move towards its magnetic susceptibility. So its formula is chi is equal to capital N P square mu B square Z divided by 3KT is equal to C upon T is equal to C upon T. Means it is the chi. It is chi is the susceptibility of that paramagnetic material. Chi is the susceptibility of paramagnetic material, and here we show that it is the T. Means chi is inversely proportional to the T. Chi is inversely proportional to the T. Therefore, it is equal to C upon T. It is also inversely proportional relation. So, what is C? C means Curie constant. Okay, we called it as C is Curie constant, and above equation is called as Curie law. Okay, this is the Curie law. Sometimes it asks, okay, write the equation of Curie law. So it is the equation chi is equal to np square mu b square z divided by 3kt is equal to c upon t. It is called as Curie law, and c is called as Curie constant. We called it as c as the Curie constant. So it's the relation between uh, temperature uh, and magnetic susceptibility. The relation between magnetic susceptibility chi. Chi is the magnetic susceptibility, and T. Okay, chi is the magnetic susceptibility, and T is the temperature. T is the temperature. So in this figure, what happens? Figure shows that the temperature variation of magnetic susceptibility in case of paramagnetic material. This is for only paramagnetic material. So what this diagram shows that on the x-axis there is the temperature, on the y-axis there is the magnetic susceptibility, and this relation is strongly agreed. This relation is strongly agreed to this diagram. So this diagram clearly shows that as the temperature increases, so here on the x-axis, when we move towards the x-axis for longer values, okay, its temperature increases. When we increase the temperature, for example, it is 100, 200, 300, 400, 500. When we increase the temperature up to certain limit or more than that limit, so what happens? This is the susceptibility. Okay, this is the susceptibility value. It is the decreases when temperature is increases, means it is the inversely proportional relation. It is inversely proportional relation. Chi is inversely proportional to T. Chi is inversely proportional to T. Okay, in this equation clearly shows that its magnetic susceptibility is inversely proportional to the temperature, and its magnetic susceptibility is positive. Here there is no negative sign, but for diamagnetic material, when we move towards the diamagnetic material, here this is the diamagnetic material and it is the negative sign. Means it clearly indicates that diamagnetism diamagnetic material have temperature independent but negative susceptibility. Okay, and this is another point is that the substance lose their magnetism on removal of external magnetic field. Okay, or the in absence of external magnetic field, net magnetic moment is zero. In the case of paramagnetic material, in absence of external magnetic field, net magnetic dipole moment is zero. But net magnetic moment for zero magnetic field is present. And this one is the from property stronger part to the weaker part of the field. When we applied external non-uniform magnetic field, then when diamagnetic substance, it non it moves from stronger part to the weaker part of the field for diamagnetic material, and for paramagnetic material, it moves from the when we applied non-uniform magnetic field, then it moves from the weaker part to the stronger part of the field. Okay, it moves from weaker part to the stronger part of the field. uh, P. Okay, so we know that what is the P in Curie law. What is the P in Curie law? So this P is equal to P is nothing but P is equal to G into the bracket J into J plus 1 bracket complete raised to 1 half, and we know that this G, we know that this J. Okay, in previous lecture. So where P is, what is this P? P is known as effective Bohr magneton. P is known as effective Bohr magneton. And what are the examples? What are the examples of diamagnetic materials? We know the examples of diamagnetic materials. For example, aluminium. Okay, aluminium. What are the examples of paramagnetic? Here we study about the paramagnetic materials. Okay, so what are the examples of paramagnetic materials? Aluminium is the example of paramagnetic material. Then after manganese, chromium, platinum, and oxygen. These are the examples of paramagnetic substances. Okay, and what are the examples of diamagnetic substance? What are the examples of diamagnetic substance? This is the antimony, gold, bismuth, copper, mercury, water, air, and hydrogen. These are the diamagnetic substances, and these are the paramagnetic substances. Means on your exam, you must be focus on diamagnetic material and paramagnetic material also. Okay, you must be focused on diamagnetic material and paramagnetic material. Means if we ask diamagnetic material and paramagnetic material, means uh, what are the examples? Expectation, write a short note on paramagnetic materials. At that time, you must be right about the paramagnetic materials, its properties, its magnetic susceptibility, that diagram, explanation of that diagram. Okay, that equation about the P Bohr magneton. Okay, magnetic susceptibility equation, and the relation magnetic susceptibility is inversely proportional to the temperature. If we ask about the diamagnetic materials, so for diamagnetic materials, what you should need to write for diamagnetic material, you should be write a short note on diamagnetic materials. So what are the diamagnetic material? Its properties. Okay, means what happens when we apply external magnetic field to the diamagnetic material. Okay, then what are the examples of diamagnetic material? And third thing is that what is the difference between diamagnetic material and paramagnetic materials? So at that time, you must be remember about that. What is the diamagnetic material and what is the paramagnetic materials? Means you should be write proper difference between the diamagnetic material and paramagnetic materials. At that time, you need to provide the information about diamagnetic material and paramagnetic material. Okay, then the next part of that is we want to move toward the after diamagnetism and paramagnetism. We need to study the ferromagnetism. Okay, we need to study the ferromagnetism here. So what happens for the ferromagnetic material? Okay, in ferromagnetism. Okay, so previously we study about the diamagnetic material and paramagnetic material. Now the next property of magnetic material is ferromagnetism. Okay, it is the ferromagnetism. So what happens for the ferromagnetism? It is strongly related to your paramagnetic substances. Okay, means its properties very well match with the paramagnetic material but large content. Okay, so what is the ferromagnetic materials? So ferromagnetism. What are the ferromagnetic material? The substances which are strongly attracted by magnetic field. We call it as ferromagnetic substances. Okay, which are the ferromagnetic substance. In the paramagnetism, it is also, but it is the weakly attraction. Okay, means weakly attraction in paramagnetic material, and in ferromagnetic material, the substance which are strongly attracted by magnetic field. Then we called it as ferromagnetic substances. So, what are the properties of ferromagnetism? First property is that it is strongly related to your paramagnetism, but large content. You know that it is the strong, okay, and it is the and it is the weakly attraction. Okay, it is the weakly attraction and it is the strongly attraction. So that's why we called it as ferromagnetic material. So properties is that the properties of ferromagnetic substances are similar to that of paramagnetic substances, but large extent, but in large extent. So means similar properties, just like that, just like when we place in non-uniform magnetic field, then it moves from the weaker part to the stronger part of the field. Then after that, in absence of external magnetic field, net dipole moment of atoms is zero. Then after that, net magnetic moment. There is some net magnetic moment at zero magnetic field. Then these are the some properties of ferromagnetic materials. And what are the examples? What are the examples of ferromagnetic materials? We call it as iron, nickel, cobalt, steel, etc. are the examples of ferromagnetic substances. And some of your colleagues are working on the ferrite samples also. Okay, ferrite samples also, that are samples which are also having some magnetic properties. Okay, and that falls to category of some diamagnetic material, paramagnetic material, ferromagnetic material, antiferromagnetic material, ferrimagnetic materials. Okay, that are working on that materials. And some working on bismuth ferrite, someone working on nickel ferrite, someone working on other ferrites properties, zinc ferrite, etc., etc., etc. Okay, so that are the properties of diamagnetism, paramagnetism, and ferromagnetism. Okay. In next lecture, we want to study here some other property, just like its hysteresis loop. Okay, and other relation means antiferromagnetic material, ferrimagnetic material, its domains. Okay. So what is Curie temperature? What is the effect of Curie temperature, etc. property we want to study in next lecture.